15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us. This is the Space Nuts podcast, episode number 222. Now, Australians will understand the inflection I just did. This episode is dedicated to the late, great Richie Benaud. Now, for those who have no idea who Richie Benaud was, he was a great Australian cricketer, but probably better known for his years and years of cricket commentary on the Channel 9 television network in Australia, where he had this rather unusual inflection with the number two. He'd say two. And so if someone got out for 22, he would say it like that. So in memory of the great Richie Benaud, who everyone in Australia adored, this episode is for him. And we welcome, as always, our good friend, the Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
Hi, Andrew. How are you going?
I'm well. You'd actually be old enough to remember Richie's playing career.
Yeah, I could, yeah. So does Gregory Peck, by the way.
Yes, he's joining us today. Hello, Gregory. See, that was his cue, and he said nothing. Isn't that typical? Yeah. Never work with children or animals.
That's right.
The old adage. How are you, Fred, by the way?
Well, thanks, Andrew. All good. Yeah, all good, yeah.
That is good to hear.
And I hope you are.
All right, coming up, I am quite well, thank you, yes. We are going to be talking about Mars today. Because they've released some data that they've had stored away secretly, waiting for the opportune time to tell us about some things going on with the South Pole. It looks like they've found some pretty significant lakes, which I assume are frozen, but we'll find out more about that. And the Square Kilometer Array. This is a huge project, one that Fred has a direct connection with. And there's some news on what's happening there. We will also answer some questions. Will in Phoenix continues his fascination with Venus, but now he's focusing on the moon. We'll hear from Will a little later, and Paul in Sydney's got a question for us as well. Fred, let's start off on my favourite place in the entire universe, the red planet Mars, and this announcement, I suppose, from I'm gathering the European Space Agency about this finding around the South Pole.
Yeah, that's right. It actually builds on work that was announced more than 2 years ago, which you and I have spoken about before, the discovery of a lake of liquid water underneath the ice cap at Mars's South Pole. Quite a big one, 20, 30 kilometres across, and liquid. And it's revealed, not by somebody going and digging there. It's revealed from an instrument called MARSIS, which is an acronym for the Mars Advanced Radar for Subsurface and Ionosphere Sounding. And it's on, as you say, the European Space Agency's Mars Express spacecraft, which is that's been going since 2003. It's a fantastic machine, still going strong, still working well. So what was discovered back in 2018, excuse me, were radar reflections from the upper and lower surface of this lake. I actually I should have dug it out. I've got the paper, the original paper that was published with these results in them, and it's quite spectacular. It's almost like looking at a cross section through the Antarctic ice cap, and you see this area where there's definite delineation of the boundary between ice and liquid water, and so that prompted a lot of speculation about how it stays liquid. It's partly because there's something like a kilometre of ice on top of this. So there's a lot of pressure there. Even in Mars's 1/3 Earth's gravity, there's still a huge amount of pressure pushing down, which depresses the freezing point. But it's more likely that there is a high concentration of salts in that water. So, it's perhaps brine with a very high salt concentration, which acts as a natural antifreeze. So possibly these materials called perchlorates, which we know depresses the freezing point of water. We found those, NASA scientists actually found those on the surface. So that's the backstory. What has happened now? And this announcement actually comes from one of the team members, whose name is Graziella Caprarelli, who is not in Italy, but is at the University of Southern Queensland in Toowoomba, a university with which I have a close association as well. So I'm delighted to be able to spruik their work. She's involved, she's part of the study team who've found, the big announcement, more lakes underneath the south polar cap of Mars. A kind of what she describes as satellite lakes. So you've got this, what is really the principal water body, which is the big lake, but somehow there are connections, possibly by channels through the ice that can't be detected on the radar. Those connections perhaps link these smaller bodies of water, which have been detected by new data from the Mars Express spacecraft. What's astonishing is that the temperature in those lakes is thought to be, let me find this, but I think I'm remembering correctly, round about minus 70 degrees Celsius.
Well, that's pretty chilly.
It's very chilly, and it's very chilly to have water at that temperature, liquid water. And so another comment that has been made by Dr. Caprarelli is that maybe what we're seeing here is also linked to the climate history of Mars. In other words, those lakes may have formed when Mars had a warmer ambient temperature. And what you're seeing is some sort of relic of the conditions that existed when they were formed. That suggests perhaps residual heat somewhere, and it may be that's coming from the subsurface rock of the planet. I'm not quite sure what she had in mind. I haven't actually seen the paper that refers to this work, but nevertheless, it's a really interesting discovery, and of course, it leads to speculation. First of all, are there more lakes down under the southern ice cap of Mars? And are there any under the north polar cap of Mars? Because none have been detected. And, well, that might just mean...
Well, the South Pole's at the bottom, so that's where all the water drains.
That'll be right. Gosh, there's some good physics there, Andrew.
Oh, yeah. I know my stuff.
Yeah, you know your stuff, yeah. I wonder why it all doesn't run off at the bottom. Never mind. So, yeah.
And there is evidence of this kind of situation on Earth. It's not unique to Mars.
Yeah, that's exactly right.
We can draw comparisons with our own planet.
Yeah, we know there are lakes underneath the Antarctic ice cap, and one that I hadn't heard of. This is in Antarctica. It's called the Don Juan Pond, which is actually on the surface. This is a surface pond in Antarctica, which never freezes, and that's because its salinity is very, very high. It's higher than the Dead Sea, so the salts in it keep it liquid. So that's a good sign that we might find, that it's probably the salinity of these lakes under the Martian Antarctic ice cap that is keeping them liquid. There's one other little snippet here that's not in the release that you and I are looking at, but when Phoenix, which was a spacecraft that landed in Mars's northern Arctic back in 2008, I think. Yes, it was 2008. When it landed, the exhaust. What Phoenix discovered was that just beneath the subsurface soil, a matter of millimeters beneath the surface soil of the Arctic region of Mars, there is a permafrost of water ice. It's just solid ice beneath it. And so the thinking is that as the Phoenix spacecraft landed, it had retro rockets firing downwards. That melted the ice and allowed droplets of water to form on the struts of the spacecraft as it landed. The little, it's just like a platform with legs on it and a couple of, a backhoe scoop. And the reason for that is that some of the cameras showed droplets on the legs of the lander, which actually changed their position. They ran down the lander. So they remained liquid, even though the heat source had been removed. And the suggestion was that that was because of these perchlorates. And indeed, when the contents of the ice itself were analysed by Phoenix, it was found to be very rich in perchlorates, these natural antifreezes. So, so you can get liquid water on the surface of Mars from time to time, as well as getting it on the surface in Antarctica, even in temperatures way, way below the normal freezing point of water. It's great stuff.
I think not so long ago, you and I talked about a breakout of water. I think it might have been in a crater on Mars or something. They'd taken a photo sometime earlier where they showed nothing, and then a photo again some time after that, and all of a sudden there was water there. So it had broken through and pooled or frozen on the surface. So it does seem to happen. The other interesting aspect of this story, and I know people are probably thinking it, could it be, because it's liquid water, could it be harbouring life? And the report suggests it's not impossible.
I think that's right. Yeah, that would be the answer I would have given you. Not impossible, because we know that there are living organisms in highly salty water here on Earth. We call them fish. Yeah, but there's microbial life can survive very high levels of salt concentration. So, yeah, who knows? It's hard to know how we might explore that, though. But being the curious...
Well, that's the hard part. If you've got 1.5 kilometres of ice above these lakes, how do you get to them?
Yeah.
And that is the challenge. I suppose sometime in the hopefully not too distant future, they'll find a way. A robotic drill of some kind, I don't know, but it would be wonderful to investigate. And there are so many more opportunities like this starting to open up. We're starting to find all sorts of places around our own solar system where liquid water exists, and who knows what's in it. That's the big question.
Exactly. Watch this space. Ta-da!
Looking for biomarkers. Yes, indeed. All right, that's exciting news. You're listening to the Space Nuts podcast, episode 222 with Andrew Dunkley and Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated number 1 by Tech Radar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/ space. That's TRYEXPRESSVPN.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
This is the Space Nuts podcast. Andrew Dunkley here with, of course, Professor Fred Watson. Oh, and by the way, thanks to those who have been supporting the podcast through social media. Whatever platform you use, we appreciate it. Sometimes you talk to each other. Sometimes you just listen in through YouTube. And whatever way you find us is wonderful. And we're getting some really wonderful feedback, some amazing letters and notes, not necessarily with questions, Fred, just people wanting to say, love the show. I'm going to sign up as a patron. Just wanted to let you know. Although I do have one, I wonder if I should bring it up. Yeah, I'll bring it up now, Fred, because I think it's a good thing to ask. There's a fella who I've swapped a few emails with. He just wanted to say hello and say how much he enjoys the show and that he'll sign up as a patron soon. He's also wanting to buy a telescope, probably a second-hand one, and he wondered what you would recommend.
These days, we're spoiled for choice, and among the new telescopes, there are ones that are really pretty easy on the pocket because of the fact that the optical industry in China 20 years ago or so brought down the costs of instruments like that. I would go online, have a look. There are telescope shops and suppliers all over the world. Certainly, there are several in Australia. Who are usually run by people who are keen on astronomy anyway. So they're not interested in making a fast buck. They just want to get people into the hobby and excited about what the stuff that they're excited about. There's no straight answer to what should I buy, because it depends on how much money you've got. And if it's secondhand, it depends entirely on what's available. But normally, people with a modest budget are looking and whose aims are really to do a bit of sky watching, explore the sky a little bit, maybe not dwell on deep sky photography, which means taking images that need long exposures with a digital camera, perhaps just using the eyepiece. Then a Dobsonian telescope, which is a fairly simple piece of kit, based on a wooden box, which forms the base of it, and a tube which contains a mirror and, well, actually 2 mirrors, one at the bottom to focus the light, one nearer the top, which sends the light out the side where you place it, where there's an eyepiece to magnify the image. And you can get, something like a 6-inch, as we used to call it, Dobsonian, 150 millimeters, for a really reasonable price. The second hand, you probably get one for a couple of $100, $200 or $300, but they're not much more than that new. And something like that is a really good introduction to the sky, because you can easily move it around, look at things like the moons of Jupiter, the rings of Saturn. They all would show up in a telescope like that. But if you want to do serious astronomical photography, that's not for you. You need to spend a lot more money for that. That's it in a nutshell.
Fair enough. No, it'll give him a starting point. There you go, Michael. Michael is in Cincinnati, Ohio, a long-suffering Bengals fan like myself. They seem to find new ways of losing, do the Bengals. But anyway, I'm still confident they'll make the Super Bowl this year. Anyway, let's move on, Fred. Thanks for helping Michael out, by the way. Let's talk about the Square Kilometer Array. We've talked about this before, but there is a new piece of information that will make a lot of people very happy about this project.
Yeah, big step forward. So this is a telescope again, but a very different kind of telescope. This is the SKA is an acronym for Square Kilometer Array. And it basically is a mega science project to build the world's largest and most sensitive radio telescopes. And there are 2 of them, one in South Africa, one here in Australia. The South African facility has the mid-frequency range of antennas. So they're steerable antennas, very much like what we think of when we think of radio telescopes. But the Australian component is the low-frequency component. Australian radio astronomers are world leaders in low-frequency radio astronomy. And that needs a very different kind of telescope. It will be placed in Western Australia on basically a very, very remote territory, which belongs, in fact, to the Wadjuri Yamaji people. And so there is a fantastic land use agreement with the First Nations people that actually own that territory, the traditional owners. So it's out there where there are really no radio signals at all from human origins, like no mobile phones. It's probably one microwave oven somewhere, but it's in a Faraday cage to keep the radio emissions in. So it's a very, very radio quiet site. And what we will have is actually about 131,000 antennas that look more like Christmas trees. They're just like 2 meter tall Christmas trees made of metal. 131,000 of those will be the antenna for the what's called SKA low, the Square Kilometer Array low frequency station, essentially. That covers something like 65 kilometres, I think, of territory in remote Western Australia, about 350 kilometres northeast of Geraldton. So that's all in the offing, and the planning that's gone into this is amazing. There are 15 countries that actually support the project. But the reason why it's in the news today is because yesterday, as we're speaking, the 29th of September, something called the SKA Observatory Convention. This is a treaty. That treaty, whilst it was signed in March last year, had to be ratified by the requisite number of countries, and that means putting it before their parliaments who vote on it. And that ratification has now taken place in Australia. So that is the big news from yesterday. So what it means is that Australia, having ratified the SKA Observatory Convention, we join South Africa, Italy, and the Netherlands, who've also done that. And it needs one more country to complete the ratification before the observatory itself, something called the SKA Observatory, can come into being. I know this sounds like minor details in a scientific project, but this is all part of the fundamental structures that need to be in place before you run.
Can it be any country, or are there only specific or certain countries?
Yeah, it is actually. Well, in terms of ratification, that we are waiting for the UK. We expect that to happen probably within a month. Why does it have to be the UK? Because you have to have the three host countries, and that's South Africa, Australia, and the UK, which hosts the headquarters of the SKA. They have to ratify the convention. So, as well as two more, and those two more are actually Italy and the Netherlands, who've already done it. So, hopefully, by the end of this month, this coming month, the new organisation, which is called the SKA Observatory, will be established. And that means then you can start doing things like employing people and letting contracts, approving the designs for the telescopes. And, you know, that's why it's such a big step that we have now undertaken the ratification. Lots and lots of benefits all around. And that's one reason why this forges ahead in what is a really difficult economic climate for the world, as we know. We're under no illusions about that. But there are all kinds of benefits which come not just from science. I mean, science is really the leading reason for doing this, to put astronomers from SKA countries, and in particular Australian astronomers, right at the forefront of astronomical discoveries, because this facility will have 10 times the sensitivity of anything that exists today. So it is going to be a game changer in radio astronomy. But of course, economic benefits too, because you've got businesses involved with the construction, not just here in Australia, but elsewhere. You're developing absolutely cutting edge technology which will have spin-offs, a bit like Wi-Fi, which came from radio astronomy. New technologies. There's an expectation of something like $2 billion Australian dollars worth of jobs and services flowing into actually the Western Australian economy for the first 30 years of operation. So these are all the things that we expect to come from that. It's a great project. I'm not just talking it up because I work in the department that is doing all the framework stuff for this, but it is very, very exciting from an astronomical point of view. I will keep everybody informed on how things go, but I expect that you and I, within the next couple of months, will be able to talk about the setting up of the SKA observatory, which is the next big thing.
Yeah, and it's as you mentioned, it's a black zone. It's very remote. It's also a part of Australia that gets mighty hot. So I dare say that they will need some pretty good maintenance staff to keep an eye on that. I'm wondering, one of the jobs will be given the amount of area that this is going to cover, there are going to be people out on their quad bikes going from antenna to antenna with their polishing rags and getting the dust on all this. It's going to be really interesting. I'm sort of half joking, but they will have to get out there and check them all out regularly.
That's right. So there are local staff who will be certainly involved with doing that. These will be fairly standalone, these antennas. They don't need the same kind of maintenance as a steerable dish does because they don't steer. You steer it electronically, which is a really bizarre concept, but that's what you can do with low-frequency radio astronomy. I've been there actually, Andrew, to the site because there are precursor facilities there already. Something called ASCAP, which is the Australian Square Kilometer Array Pathfinder, and something called MWA, which is the Murchison Wide Field Array, which in some ways resembles the Christmas trees of the final thing, except they look like coat hangers on the ground, the MWA antennas. So these facilities are already there. It's a place, as I said, I visited. Really intriguingly, the day that I visited this desert facility, it absolutely poured down. We all got drenched. This was probably a slightly oddball day. There was the remnants of a cyclone, I think, which were blowing in, and so there was a lot of rain around northwestern WA. So we got wet, but everything seemed to survive okay because it's built to withstand rain as well as heat. There are perhaps the biggest threat to the antennas is occasionally you get camels wandering through that area, and they're quite big compared with a metal Christmas tree. And so there is a hope that the camels will stay away. Perhaps they need to put signs up saying, no camels here, please, or something like that.
Yeah, but they might have to write that in Afghan.
Yeah, that's right. That's where they came from. Arabic.
That's right. That's what I was trying to say. But we drove back from the Hunter Valley the other day, and I saw two camels.
Oh, really?
Which caught me off guard. I think they were on a farm, but
I think it
was a bit strange to see camels in the Hunter Valley. But they don't usually come this far east. But do we have a set date or year or time frame for completion of this construction phase?
Yeah, and it's so the timeline is okay. The observatory is going to be created within the next couple of months. That should lead to contracts being let and things of that sort. So by this time next year, construction should be well underway. It'll probably start in the middle of next year. And it's a big job to put something like this together. So the science commissioning, which is when you really start tuning into the universe, is scheduled for 2024-25, with full operations a couple of years later, 2027-28 for the completion of the construction and the start of full operations. And that's when I don't know whether you and I will still be on air by then. I bet we are.
I hope so.
Yeah, I hope so too. So then we'll be able to talk about what this thing's going to do, because it's be able to probe the entire history of the universe. It's really an astonishing capability. And some of the big questions that face astronomers things like dark energy. Are there new physics in gravity? That's something that we might be able to find out from this instrument. Something we don't really understand: magnetic fields in space. Where do they come from? How were they? How did they originate? And where did the first black holes come from? Things of that sort, as well as the perennial question, Andrew, that you and I discuss all the time: are we alone? Because, as I've said many times, this telescope will be capable of detecting an airport radar at 50 light years. So, if there are any airport radars in our vicinity and they're operating, this telescope should be able to find them.
Oh, it's exciting! Can't wait. This, this could be a groundbreaking instrument. We'll watch with interest. But good news that we're almost past the bureaucracy and into the construction phase, which is fabulous news. You're listening to the Space Nuts podcast with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
Once again, thank you to our patrons. I mentioned patrons earlier on. If you are a patron and you're putting a few dollars in the kitty every month to support the podcast, thank you. Thank you from the bottom of my heart. And to those who have made the promise, we also say thank you. If you would like to become a patron, you can find out all about it on the Space Nuts website. That's bytes.com/spacenuts, B-I-T. Oh, no, we've got a new URL, haven't we? spacenutspodcast.com. That's all you need to do. And I think there's a little tab where you can find out about becoming a patron and how it all works and what the options are. There's all sorts of different platforms you can do it on these days: Acast, Patreon, Supercast. They're all available to you. You can use them all if you like, but if you have a preference for one over another, those options are available via our website, spacenutspodcast.com. Now, Fred, we have some questions to try and resolve, and we've heard from Will in Phoenix before. He was quite fascinated by Venus, but in answering his last question, it appears we've prompted a new question. How very odd.
Good morning, Fred. Good morning, Andrew. Thank you for answering my last question. This is Will in Phoenix. I find it super fascinating that Venus's rotation has been slowed because of tidal braking. I thought it was too far from the sun for that to be such an influence, but obviously I was wrong. That's very, very fascinating, because I know the moon has done the same thing with Earth. So the moon's orbital period and rotational period are the same. And speaking of our moon, with Artemis getting ready to launch here from the United States, hopefully early next year, if we're going to the moon with a more sustained presence, Fred, as an astronomer, I'd love to hear your opinion as to putting some sort of a telescope system on the surface of the moon. I can only imagine putting something like the Very Large Array on the moon would be substantially more advantageous than on the surface of the Earth. And given that it has a solid surface to mount to, even more advantageous than doing like a space-based telescope, something like Hubble or even the James Webb. As awesome as all those tools are, I can only imagine if you could do something super huge on the surface of the moon so it's stable and there's no light pollution, it would be the most beneficial. Anyway, Fred, I'd love to hear your thoughts, especially as a professional astronomer.
Thank you, Will. He brings up an interesting point. Of course, much less of an atmospheric interference issue with observable platforms on the moon. He mentioned the lack of light pollution, but I would suspect that the reflection of the sun off the Earth might be a huge source of light pollution for an observatory of some kind on the moon. What do you reckon?
Yes, that's right. And of course, you've got 14 days of daylight on the moon and 14 days of darkness. It's kind of a bit like Antarctica, where you've got 6 months of darkness and 6 months of daylight. But there is an advantage, particularly for radio telescopes. There is an advantage in putting a telescope on the moon, and that is if you put it on the far side of the moon, the backside that never faces the Earth, and you put your large radio array there, you've got the bulk of the moon shielding you from extraneous radiation. So it would be the most radio quiet place in the Earth-Moon system. And that's something that people have certainly thought about. The advantages are less so for optical telescopes. And in fact, your point is well made with things like sunlight affecting the view. So as soon as you get away from the atmosphere, you don't have the blue of the sky getting in your way when it's daytime. But there's still issues with scattered light in the telescope. If you've got the sun shining on the telescope and it's looking at some black stars somewhere, there are scattered light issues. And that has all been dealt with, certainly with the Hubble telescope, with baffling and shielding and things of that sort. The James Webb likewise has an infrared heat shield to stop the heat of the sun warming up the telescope structure, because the James Webb telescope is an infrared instrument. So you can deal with these issues in space with basically with optical and infrared telescopes. But once you get to radio telescopes, it's a lot harder to shield from radiation. Having the moon between you and the source of what's called RFI, radio frequency interference, is a lot better idea. So I'm with Will on the idea of putting a large array on the backside of the moon. There is an observatory on the backside of the moon at the moment, and it's called U22. It's the Chinese rover, part of the Chang'e 4 experiment, which is sitting in the Aitken South Pole Basin down there on the far side of the moon, and working well. Got some really interesting images from it, as well as other things.
Fascinating. All right. I think the day will come, Fred, when we do have a more significant human presence on the moon, that these things will come to pass. I'm pretty confident that that's the way it'll go. It's just so natural for humans to expand beyond their home base to see what's over the hill. And, from the moon to Mars and beyond, I think, assuming we continue to progress as a species and we don't destroy ourselves in a cataclysmic thermonuclear war or environmental disaster, leaping from planet to planet and perhaps beyond that into the future is a given. And with that will be the technology for us to do the observing, to look forward to our next leap. I think that's just natural for us as human beings, is it not?
It is, but we've got to be we have to be thoughtful in the way we do it. For example, Mars, as you know, I don't think we know enough about Mars to get anywhere near thinking about colonizing Mars. I think we need to know much, much more about the planet before we send humans there in very large numbers. I think I'm all for exploring it, exactly as you said. I think we should treat it a bit like Antarctica, where we explore it but treat it gently.
Fair point. All right. Thank you, Will, for your question. Let's move on to a question from Paul in Sydney.
Hello, Fred and Andrew. Paul from Sydney. Thanks for the podcast. Space-time is often represented as an elasticized sheet in a horizontal plane with objects of different masses from black holes to planets shown as black spheres at the bottom of more or less deep depressions on the sheet. Gravitational lensing suggests that the warping of space-time around the massive objects is in all dimensions, but I'm having trouble picturing that image. Is it, for example, like the universe being a block of Swiss cheese where the different size holes in the cheese represent different mass objects and their influence on the surrounding space-time? In an expanding universe, do these spheres of influence diminish over time as the fabric of space-time expands around them? Or would the sphere of influence expand as well? I guess that's analogous to the holes in the cheese becoming relatively smaller or drawing bigger with the rest of space-time. If the answer is that they diminish, then I'll leave a note for my future descendants in a few trillion years not to look for jobs as LIGO operators. I'd be fascinated if you could draw the picture for me Look forward to hearing. Cheers.
Okay. Tricky one, Fred.
It's a great question from Paul. And he puts his finger on it very well. You know, we talk about the distortion of space-time by mass, by any kind of matter, and we always depict it as exactly as Paul says, as an object depressing something like a trampoline, although it needs to be flexible, elasticized, as he says, and that shows how it would happen in a two-dimensional world. But it's a lot harder to imagine how that happens with 3 dimensions, but it does. And so the net result is to imagine the net result is what we imagine when we think of gravitational lenses, exactly as Paul says, something in which the space is distorted in such a way that light is bent around it. I think that the two-dimensional analog, the elasticized sheet, is really as good as we can get in terms of envisaging it, because when you extend that to 3 dimensions, it doesn't seem to make sense. But the net result is the same thing. You've got this bending of light waves. It's actually called the bending of the geodesic is the technical term, which is observed many times by these gravitational lenses, where you look at the distorted images of objects beyond a nearer object whose gravity is bending space-time. So in some senses, it is like a block of Swiss cheese. I quite like Swiss cheese. I also like Jarlsberg, which also has holes in it. That's Norwegian rather than Swiss, but never mind. So you've got holes in it, but it's not so much a hole as just a place where the space-time is distorted. And to envisage that in an expanding universe, which is the question that Paul poses, when you think about the sizes of these gravitational lenses, they are relatively compact compared with the scales on which the expansion of the universe makes any difference. So that, yes, the universe is expanding, but it's really only when you look at objects that are separated by millions, hundreds of millions, or billions of light years that it actually starts to have a real influence. So whilst, yes, those gravitational lenses are subject to the underlying expansion of space-time around them, that means they are expanding. They're not effectively diminishing. The effect is so small that it is immaterial for any future LIGO operators who might be part and parcel of it. It's a very, very small effect on small scales. It's only when you look at the large scales that the expansion of the universe becomes significant. So, it's a good question. And once again, it would be great if we could think of some way of drawing the 3-dimensional distortion of space-time. I guess we can in a peculiar sort of way. I think if you imagine the thing drawn in 3 dimensions and then rotating so that you can see the distortion, I'm sort of imagining animations that might depict it rather nicely, but I don't have the.
You would think with computer generated.
Yeah, that's right. Yes, just
these days they could do it.
Yeah, you could do it. That's right.
Okay, there you are, Paul. Hopefully, your future descendants will still be able to get a job working on LIGO or whatever. It sounds safe. Yeah. And that brings us to the end of another program, Fred. Oh, by the way, if you do have a question for us, you can send it in through the usual channels, or you can go to our website, spacenutspodcast.com, click on the AMA link or tab, and there's an option there to press the record button, and voila. If you've got a device with a microphone, it's as simple as pushing the button, saying who you are, where you're from, and asking your questions. Simple as that. So looking forward to hearing from you. And Fred, thank you again, as always, enlightening and enjoyable, and some great news to share this week, which was always good, especially about the Square Kilometer Array. That's starting to get really exciting. Not far to go now before we can start reporting data from that. So take care of yourself, Fred, and we'll catch you next week.
Thanks very much, Andrew. Same to you. Have a good week, and we'll speak again soon.
Okay. Fred Watson, Astronomer-at-Large, here on the Space Nuts podcast. And from me, Andrew Dunkley, thanks for your company. We'll catch you on the very next episode.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.